Welcome to springlib.
So if the object is very far away from the lens, then it's considered that the image is formed at the focal point, and we can actually prove that from the equation which gives us the relation between focal point and distances of object and images. So if we start from this equation, we can write the image distance in terms of the object distance and focal point, which is nothing but FDO over DO minus F. Now, as we mentioned that DO is very greater than F, so we can ignore this part, and that gives us F DO over DO. So DO gets cancelled, and we see that di is basically f. So that means if the object is very far away, then the image is placed at the focal point. And from this diagram, we see that this is the image that's forming. And if we actually take half of the angle, so the total angle that it's making is 40 degrees, so half of that is 20 degrees. So if we look at this triangle, this part is 20 degree from the geometry, and the half of the image length to focal point will give us tan 20. So we can use the relation tan 20 degrees, which is equal to height over base. So that's going to be x by 2 height divided by the base. And we can write the focal point in terms of the other two. So f will be x over tan 20 degrees. Right. So now in part A, the image distance should be the image distance is given as 36 millimeters. So f is equal to 36 millimeters divided by 2 tan 20 degrees. That's equal to 49 millimeters. So that's the focal length for a 36 millimeter image. And for part B, x is 1.6 centimeters. That's for the digital camera, which is equal to 16 millimeters. And hence f will be 16 millimeters divided by 2 tan 20 degrees, which is equal to 22 millimeters. Thank you.